Okay, so let's get to the heart of the matter here for our stacking sequence. The most important change from our 2D sequence is the opening and closing of the gripper. So, if you may recall, if you open up a target component, um, a create target component from our robot's software or plugin, it has a lot of options. If you right click on the component, these open up. And the one we want to add um, is the command input. So as soon as you see this little C shape symbol, uh, that is a command option that we have for our targets. So this is our standard target. We have the target plane. Um, we have the tool connected already, which is our gripper tool. Speed and zone, we've looked at that before. So really the only new thing is this command component. So the robot's software allows us to utilize some additional components. For example, you can wait for a signal or digital input from the robot. You can set a digital output, like send information back to the robot and so forth, okay? So the one we're using here is called set digital output. So what does that mean? We talked about that in class. It means that we're going to trigger a 5-volt signal to come out of the robot controller or box. That 5-volt signal will be sent to the gripper controller, and it'll tell the gripper, hey, you need to either open or close. So how do we tell the gripper whether it needs to open or close? Well, we're using two separate slots, slot 0 or slot 1. These are the slots, think of them as wires coming out of the controller on the robot and going into the control box on the gripper. So if you set a true and false toggle uh, on on slot 0, it's going to be um, set up in our control software for the gripper to either open or close. In this case, true equals open for our controller on the gripper. In the same way, if we want the robot to close, we can have true equal to close on slot 1. So this is all very arbitrary. It depends on the way that the code is written on the gripper side. Okay, so we're not going to change these. Um, you can test them out and flip them back and forth between true and false and watch the behavior of the gripper on the actual robot. We'll have a separate video on how the control software works for the gripper. But really, what we need to just understand is that these targets are very similar to the pick up and drop off targets that we had in our paint sequence. The only thing that we've added are these control or command sequences and our set digital output, which triggers an event on the robot output, either slot 0 or slot 1, to open and close the gripper. That's really the only new thing that we've added. Other than that, I've got a lot of height adjustments set up for being able to fine tune where the gripper opens and closes. And you'll also find these little wait for gripper close. These are kind of like delays so that you have a little bit of time to adjust the stick or pause the robot if necessary. And that's pretty much it. We have a series of these. They're set up in a sequence so that we can move back and forth between the pickup cycle and the drop-off cycle. These are woven together, much like our paint. They're merged in this case, much like our paint cycle. And then they're sent to our program, and if we have no errors, then we can continue to simulate. So very, very similar sequence to what we had before with painting. The only really added complexity is your understanding of the correlation between whether or not the gripper is set to open or close or to trigger an event on our robot. So we'll go over what that means from the perspective of the gripper controller in a separate video.